Now let's talk about WebRTC in the real world. Up to now, we have told you that WebRTC enables communication peer-to-peer, no servers involved. Well, that's not entirely true. Let me explain to you why. There are some components that require a server. These are signaling, the ICE and the smoothen servers, and optionally a media server. We will discuss the latter in a future topic. So this is the picture we currently have about WebRTC. While it is a great depiction of how WebRTC calls work, it has a fault. It doesn't work. Well, the problem here is that you can't communicate with something that you don't know. Both peers need to know where to find the other in order to be able to establish a connection. And that is where signaling enters. A signaling server sits in the middle of both peers and allows them to exchange information about themselves prior to initiate a call. Then, after such exchange, both peers now know how to find each other and hence are then able to connect peer to peer. So a signaling server is only required before the call. In the image, we can see that the first step is that browsers get access to user media devices, making use of the Get User Media API. After that, they exchange some information about themselves using the signaling server. And after they finish such process, they are able to connect peer to peer. So signaling is the process of coordinating communication through an exchange of messages. What is the information containing those messages? These are codecs, bandwidth, media types, IP addresses, etc. So how does signaling work? After getting user media and creating the RTC peer connection, the browser creates an offer that contains information about itself. Such offer is sent to the signaling server to the other peer, which will receive it, and that creates an answer. Such answer is returned to the first peer again through the signaling server. These messages are formatted using the session description protocol and contains all the information that we mentioned before. After both peers have exchanged these messages, they are able to initiate the call. Another process that takes place in the signaling server is the exchange of ICE candidates. They work similar to the offer and answer that I explained earlier. We will still talk about this in a minute. Signaling is not part of the WebRTC standard, so you can build it anyhow you want. And there are even some third-party commercial cloud messaging platforms that provide such services. Examples of that are Pusher, Casing, and Putnub. Some of the technologies you can use to set up your signaling server are WebSockets, SIP, and XMPP plus Jingo. So now we have signaling in place. Does that mean that we are now able to establish our WebRTC call? Wrong. There is still one topic left we need to discuss, and that is the ICE framework stun and turn servers. When you're ready, move to the next lesson.